Okay, today we are going to talk about arithmetic sequence. Okay, so first we need to understand what is an arithmetic sequence. Okay, so that's the definition. Okay, and arithmetic sequence is an sequence with a common difference. Okay. Okay, first of all, we need to understand what do we mean by common difference, right? So that says, so the term, so for each term, it will be a common difference from the previous term, okay? So for example, 2, 5, 8, 11 is an arithmetic sequence, okay? Because it has a common difference. How could we find that common difference? You just use the term, take away its previous term. For example, the second term is 5. When you take away 2, you get 3. So the common difference is 3, right? Okay, so you can see it's always add 3 going to next term. Okay, and so on. So that's what we call an arithmetic sequence. Okay. And secondly, how can we represent our arithmetic sequence? Okay, so there are two ways to do so. One is what we call recursive. There's a recursive rule. So recursive rule, you can use the rule like this: Tn equals Tn minus 1 plus a common difference. Okay? Okay, so Tn means nth term, right? So that's nth term. Okay, Tn minus 1 means its previous term, n minus 1th term, and that's T is the common difference. Okay, for example, when you look back to previous example, if you want to have a recursive rule for the above one, the recursive rule will be, for this one, right? So the recursive rule. So the recursive rule, Tn equals Tn minus 1 plus 3 with T1 equals 2. Okay. Right, so when you put T1 equals 2, and if you want to find T2, it becomes T1 plus 3 becomes 5. Okay, so that's the first way to represent it. And there's another way we call expressive rule, and this one is more important. Expressive rule. Okay, so expressive rule, we use this one: Tn equals T1, so that's the first term, right? Plus n minus 1 times d. Alright? Okay, so why we have this rule? Okay, so let's look back for the previous example. If you can see, from the first term to second term, it's first term plus one common difference, 3, right? But when you go from the first term to the third term, you need to add 2 common difference. Okay, so if you go on with that logic, you understand that for nth term, it will take you n minus 1 common difference to add to T1 to get the Tn. Alright? Okay. So as I've said, So explicit rule is more important. So how can we identify these necessary polynomials in the explicit rule? Okay, remember for the explicit rule, you will have Tn, okay, this term, okay, alright. So remember Tn's nth term, okay, so it's nth term. That's why I should use another color, sorry. So the nth term, and that's the first term, and that's n just number of terms, okay. So this is the number of terms. Okay. D is the common difference. Alright? Okay. Okay, so let's do some simple examples. So this example will be very simple, very basic. So they will be simple, familiar if you see them in the examination, right? Okay, so for example 1, you got a pattern. So we give you a pattern that's 3, 10, 17, 24. Okay. So question A is find the common difference. Okay, you might pause the video now and try to take 1 minute, try to see if you could find the common difference, right? And B, can you find the 25 term? Okay. So as I've said, you might take some time to do it, but I'm going to compose you the video. You can pause it if you want. Alright. Okay, so for this question, if you are going to find a common difference, okay, remember how to find the common difference. You could just use the second term to take away the first term, right? Or the third term take away the second term. So I'm going to use second term to take away the first term. So the common difference is 7. Okay. Can we find the 25th term? Sorry. Okay. Remember our general rule or our explicit form, right? So let's use this form again. Let's use this form again. Okay. So I'm not going to find the 25th term, so that n will be equal to what? 25, right? So let's write T25 equals, so what's T1? T1 means the first term, that's 3, plus n means the number of term, okay, and which term you are interested in this time. In this case, it should be 25th. So n is 25th minus 1. And what's the common difference? It's 7. Okay. Okay. So of course you know that you have to do the 25 minus 1 first. Okay. So that would be our equation. You can use your calculator to find it. So that would be the case. Okay, so that's how we use explicit form to find a particular term. Okay, so let's have a look at second example. Okay, so this one is also simple, familiar. Okay, this time we are going to give you the explicit rule. So the explicit rule is okay. Here's a misspelling. There's no E here. Okay. The explicit rule is an arithmetic sequence is represented by the rule Tn equals 3 minus 5n. Okay. So you might think, okay, so we've just said that explicit rule will be something like Tn equals T1 plus n minus 1d, right? But now, why the term appears like this because we got the values. We possibly have plugged in the values of common difference and also the first term. Okay, so that's why it look a bit different from previous form. But actually, you could see we still have the essential variable here, that's n. Okay, which means if you are going to find the number of terms, you still need to plug in the n. Okay, so if you have that rule, how could you find the 100th term? Alright, okay. So again, you might pause the video and try to think it for a while. Try to work it on your notebook, and you could track the answer after I give you and show you the solution. Right? Okay. Okay. So let's see how could we find the answer? Find the 100th term. Okay. So that means this one. Okay. So the answer will be minus 497. Alright. Find the common difference. How could we know the common difference? Okay, remember that last time, how could we find the common difference? We just used the second term minus the first term, right? Do we know the first term, second term? Of course we don't, but we could use that rule to help us to find the T1 and T2, right? So let's find T1 first. So T1 means 3 minus 5 times 1. That's minus 2, okay? And T2 means 3 minus 5 times 2. That means minus 7, okay? Okay, you see that's minus 2 and minus 7. How could we find the common difference, okay? So remember common difference, you always use term to take away its previous term, okay? So if you use T1, it has no previous term, right? But if you use T2, its previous term is T1, okay? So let's use T2 minus T1. So it's minus 7 minus 2, right? So it becomes minus 7 plus 2, alright, plus 2, that's minus 5. Okay, so the common difference is minus 5, okay? Okay, C, write the recursive rule for the sequence. Okay, so remember the recursive rule is just like Tn equals Tn minus 1 plus the common difference. Okay, and also you need to get the T1. Okay, so what's the common difference? It's minus 5. Okay, so just minus 5. And what's T1? T1 would be, alright, T1 is minus 2, so that's a recursive rule, alright? So for this video, you should know what's the basic definition of our arithmetic sequence, what's its property, the major property is the common difference, and also there are two ways to represent our arithmetic sequence, recursive rule and explicit rule, and also need to identify the important polynomials in that's the explicit rule of the arithmetic sequence. Okay, and also we show you two simple and familiar example. Alright, the first one is given the pattern, right? The second one is given the explicit rule. Okay, alright, so try to review it from time to time because this is very important. Alright, okay, see you next time.